Hello friends, in this lecture we are going to learn about virtual circuit networks. So till now we have studied about datagram network and circuit switched network. In a datagram network, so if there is a sender and there is a receiver, then the packets or the datagrams that are being sent, they are all independent of each other, which means they can take different path. Packet 1 might take this path, packet 2 might take this particular path. Okay, so delays can be different, they can be out of order, and you have no guarantee of service that okay your packets will reach. But here in circuit switched network, it's like a telephone network. So when you are talking, so first you make a call setup and then you reserve resources. Okay, it means that I'm saying now I'm reserving this particular path and I'm having guaranteed bandwidth for my telephone call. Okay, that is circuit switching. Both of them have their benefits and disadvantages. Okay, so for example, datagram network, there is more resource utilization. Okay, there will be more bandwidth, more users can be allocated. In a circuit switched network, so you have resource allocated to the users, so if they are not active, they are going to be unutilized, and bandwidth or the network resources are underutilized. So these are the two endpoints. So there is something in between these datagram and circuit switched network that is known as virtual circuit. A virtual circuit network is a cross between a circuit switched network and a datagram network. So it has a characteristic of both with the aim of having best of both the worlds. Okay, so it has something good from datagram network, something good from circuit switched network. So here it is based on the datagram network. Okay, but we have, so you will have packets, okay, flowing from source to destination, but unlike the datagram network, they will be following the same path. So for this we have here the three phases are there. So call setup phase. Okay, so there is a setup phase, then there is data transfer phase, and there is tear down, and the efficiency is good. What is the delay? We will look at it. So let's look at this example. So this is the switching network. So these you can assume as routers. Okay, the end systems are A, B, C and D. They can send packets to each of them, okay, each other. So now what happens is, if in a datagram network, if A was sending packet to B, then first packet could have followed this path. The second packet, if there was congestion, would have followed this path. So, and in fact packet 1 might have reached later than packet 2. So out of order it can be. There is no guarantee. If packet loss is there, then it's just best service, possible service is there. In a circuit switched network, on the other hand, as we said, a path will be dedicated, path will be there. So here in a datagram network, if you want to make a dedicated path, so there should be a setup phase on the routers. And how it happens, let's try to see. So we have what is known as a virtual circuit identifier. Okay, so if there is a path from your previous node A to B, then we need a virtual circuit identifier. So that should identify that okay, A and B are talking to each other, so this will be my virtual circuit, and each link here needs an identifier. Okay, so that whole virtual circuit you can give one identifier, but we will see that inside this each of the link has got one identifier. So your routers or switches have ports. Okay, so there is one incoming port and there is one outgoing port. Okay, so usually in datagram network the routing takes place based on the destination. Okay, so it happens based on the destination of the packet, but here first we make a reservation of the path and then we have a virtual circuit identifier for routing. Let's see how it happens. A and B are talking, so each packet has a virtual circuit identifier, it comes to some port of this and it goes out of another port, and the virtual circuit is identifier is there for each link. Okay, so let's try to look at it. So there is a data packet, okay, and they are coming on port 1. Okay, so this is a switch, and on port 1 two packets come. So this is packet 1, this is packet 2, and this is a routing table for the virtual circuit network. So incoming and outgoing table is there. Okay, so for incoming ports, so our port is 1 and virtual circuit identifier is 14. Okay, and then for another packet it is 77. Now when this packet, let's say data with virtual circuit identifier 14 comes here and it is coming on port 1, so it looks in the table, so port 1 is there and it finds that virtual circuit identifier is 14, so it will send it to port 3 and the virtual circuit identifier will become 22. So what happens is that if this is the sender, this is the receiver, and this is the path being followed, the reserved path, then the virtual circuit identifier for each link there is a virtual circuit identifier. So 21, 35, 403, 6240. So these are the virtual circuit identifier for each link, and this whole thing tells you the path. Okay, so at each of these switches there will be a table like this, that okay, this is coming at port 21, port let's say 2, and virtual circuit identifier is 21, so it should be transferred to port 5 and virtual circuit identifier should become 35. So now you might ask that why are there so many virtual circuit identifier for one virtual circuit? Why will each link should have different virtual circuit identifier? So the reason is, if you just choose one virtual circuit identifier for the whole virtual circuit network, so what will have the whole path, then let's say I chose 1035 as my VCI for whole path. Packet is coming here, and let's say the router here already had an entry of virtual circuit identifier as 1035, then he could not have allocated this. So hence when the request phase the packet is coming, so this router will now decide which virtual circuit identifier it should give, so it should be available. So this is the source to destination data transfer. So A is sending to B, so data is there and VCI is 14. So now he looks up, so this is port 1 and VCI is 14, so this table tells us that forward it to port 3. So don't forward it to 4, don't forward it to port 2, forward it to port 3, and now give it a VCI which is 66. So I take the data, put a new VCI which is 66. Now it comes to this particular switch, it will look at port 1. Okay, I'm at port 1, VCI is 66. So where should I go? Port 2, and VCI I should put as 22. Now this packet reaches here at port 2 and VCI is 22. It should go to port 3 and VCI is 77. So this is there. Now you may ask that how are these tables allocated? So this is allocated in the setup phase. So this is the setup request. So datagram network, so initially I'm sending a packet to destination B. Now this packet goes here and this A decides the link VCI for this one. So it says that okay, I'm going here, so it says that okay, this is port 1 and VCI is 14. Then based on the destination address, it finds that okay, let's make the port number should be 3 where it should be routed. Now when it comes, and here I cannot fill this part because this VCI what should be put will be decided by this switch. So a packet comes here. Okay, so this has now, it comes to this one at port 1. Okay, Now it will say that okay, and it sees that okay, it's a setup request is there, so it puts a virtual circuit identifier 66, and based on the destination of the packet finds that okay, it has to send it to port 2. So it comes, the packet comes to, request packet comes to switch 3 at port 2, and now what happens, it can fill that okay, it is coming at port 2, it assigns a VCI, an available VCI to it, which is port VCI 22, and now this one, it sensed it's out at port 3, but it doesn't know what VCI to assign to it. It comes to B and it assigns a VCI 77. Then it sends an ACK that okay, that I am ready to receive. So this packet, when it goes, so it comes at port 3, and now this router will know that okay, the virtual circuit identifier is 77. So let's look here. So this 77 VCI comes here. Switch 3 will now know that okay, this is the ACK for your request packet. So port 2 and VCI 22 was there. Now outgoing will be 3 and VCI should be 77. This packet goes now, and for this link the switch 3 puts the VCI as 22. Now this switch knows that okay, this particular field should be 22, which was not filled here. So this one, it's filled here, this goes back here, and now it was 66 which was assigned earlier. This switch will learn it from the ACK packet and put this 66 here. So now your setup phase is complete and all the switches have their virtual circuit identifiers. So now when they see the packet, okay, the virtual circuit is 14, it is at port 1, it should go at port 3 with virtual circuit identifier 66. Then it comes here, okay, so VCI is 66, it's coming at port 1, transfer it, forward it to port 2 with VCI 22. It goes here, and now you have port 2 and VCI is 22, so forward it to port 3, VCI is 77. So this is done. And virtual circuit switching, all packet belonging to the same source and destination, so they travel the same path because we have VCI, virtual circuit identifier, and hence a route for the packet will be the same, but the packets may arrive at destination with different delays. Okay, so that is there. So I hope you understand this. Thanks a lot.